Okay, Camilo, welcome and thank you for coming on, mate. Why don't you give us a bit of a rundown of Enovate AI, what the company does, and the problems you're trying to solve?
All right. Thanks, Alan, for having me here. Yeah, we are Enovate AI. We're a technology company out of Houston, Texas. We're coming with an oil and gas, now energy background. Uh, our mission in the market is about more energy, less emissions. So we support oil and gas operators, power generation to maximize productivity and also reduce and monetize emissions. So we have been around, we have been in the market since 2020. We were born in Gulf of Mexico, Gulf of America today, very focused in the offshore market, which is obviously a very interesting, aggressive environment when it comes down to really productivity enhancement. And from that particular market, we have been growing into the land market, supporting independent companies to maximize revenue. Maximize revenue is optimizing productivity and monetizing liabilities. So we deploy digital solutions in the cloud. We have been developing physics-based AI workflows, and that covers a wide range of tools from statistical tools, machine learning, neural networks, large language models. So hopefully I can show you a little bit today. But in a nutshell, it's really about optimizing workflows. It's about really helping customers to get data and prescriptive decisions or information so they can make better decisions and really measuring ROI. That's what we do.
Sweet. And the product you deploy is it soft? So you guys are a software company mostly,
Correct. Correct.
and you don't customize specific solutions for your clients. So it's one all, and then you kind of
So
customization.
that's a great question. So customization, sometimes we do. I think, initially we were customizing a lot. Now that we have a more mature product, more customers, we kind of have a roadmap. So if there is any level of customization that really benefit a wider audience, we obviously include that development into a roadmap. There is a lot of projects, I think, in the digital space. I think we are scratching the surface, so we don't want to close doors to a big opportunity just because we don't have a workflow. But we have a comprehensive solution. Most of the time, we can cover requirements. Again, when it comes down to digital solutions and the mission about maximizing productivity, monetizing, reducing emissions, is really about the goal setting. So we kind of predefined requirements ahead of the game, and the goal is about measuring the ROI based on those goals. So we don't close the doors, but we are open to specific projects on a project by project basis.
Right. And is emissions reduction the number one goal, or it's part of it? And you do have workflows that do not touch on emissions, like subsurface workflows, particularly. I'm interested in.
Yeah, separate. We have kind of three kind of customers. Customers that want to maximize productivity. That's probably our largest market. We are very strong in offshore operations, and it's about really maximizing the use of the data that legacy systems are capturing. That's customer profile number one. Customer profile number two is customers that want to transform liabilities into revenue, and that's basically generating carbon credits by certifying emissions reduction with digital technology. And we can talk about basically a solution, but that's customer profile number two. And customer profile number three is basically the field optimization. We go maximize productivity, reduce emissions, monetize and do emissions reduction, support the commissioning of asset. That's what we call intelligent asset retirement. So it's maximizing productivity, reducing emissions, or both.
Okay, fantastic. And just curious, Innovate AI is the name of the company, or it's the name of the platform, or both? Is it you guys are a SaaS software
We are
company,
a
right?
SaaS company. Enovate AI is the name of the company. Our technology is named, the core of the technology is Ada AI. That was basically inspired by Ada Lovelace, the British mathematician that was kind of forward-looking long time ago. But with the evolution of the market, what we do, and happy to discuss more in terms of how we achieve the goals, we have a comprehensive a comprehensive ecosystem. So AI evolved into Unify, which is the point where sustainability and energy converge into this greater ROI that I'm sure we're going to talk about.
Excellent. Okay, that's cool, man. Thank you for that intro. I'm keen to see what the platform looks like. So if you don't mind,
Sure,
then you can jump onto the screen sharing and
sure,
do us a bit of a walkthrough.
sure. Let's do it. So the platform is basically a web-based sort of deployment. The entry level is just basically a visualization of the assets with some level of ranking based on priorities that we are tracking with the system. There are lots of applications. The first tool is about forecasting, which is very typical workflow. The benefit here is the opportunity to forecast based on predefined training and real-time data. Everything we do with our platform is about real-time frequency. So the main goal is the automation of the workflows at a really kind of basic level. So forecasting here is using real-time in forecasting using data in real time. Then we have a digital twin that is basically a connection between subsurface workflows, more into the reservoir engineering and production workflows and the tubing engineering. Is a digital twin. There is not really a standard definition for digital twins, but for us, it's basically a digital environment where you can simulate uh, performance of the physical asset that is connected to sensors. So all these models are updated in real time, and you have a visualization to simulate what if sort of outcomes. So what we do here, this is a model setup. We just have traditional workflows and flow performance relationship, vertical lifting profile, some level of nodal analysis. And again, the differentiation here is the connection with the real-time data. So you don't need to kind of manually update the models. The system is updating the outcomes of the model. And once you have that particular kind of digital twin set up, there's a lot of things you can do. And I'm going to go through a few things. So the first one,
Sorry,
at a
Camilo,
really
can I ask a couple of questions there? So you guys being a software company, when you come in to work with a client, do you connect here at this stage to their existing databases and historians? You don't bring your own instrumentation sensors. You're just connecting, plugging into what they already
well,
have, right?
so it depends on the customer profile. We work from small customers all the way to really big companies. Ideally, we just want to piggyback on what the customer has. Historian databases. Sometimes they have, uh, null databases. Uh, we have cases where we need to do full revamp, where we go to the field. We work with automation partners like Aviva, like Emerson. We deploy sensors. We support, deployment of SCADA or cloud-based SCADA. In offshore environments, we collect data from legacy systems, from edge devices, and stream everything to the cloud. So we kind of cover a comprehensive range of needs for the customer. But from Enovate perspective, we are software. We just have a bunch of partnerships that can support deployment based on customer requirements.
Right. And just curious, in terms of well performance, as an example, when you build the digital twin here, if
Mhm.
you work with a company that already has, a bunch of well models using their own well performance software, let's say Prosper, do you need to rebuild those models in here when building the digital twin, or also you have the ability to hook up to those existing, in this case, Prosper models as example?
Right. It depends on the goal. Yeah, like I mentioned before, we can piggyback on any sort of pre-existing workflows. However, I can tell you top three markets that we are really good at. Number one, gas lift optimization. Gas lift in oil and gas is now something that customers really focus on when it comes down to variability of reservoir behavior over time. So in that particular case, we kind of use train our own kind of tubing or lifting profile so we can have a more accurate and proactive response to all these kind of reservoir changes. That's top number one. Top number two, offshore, depleted reservoirs. That's very complex when it comes down to really understanding where the fluctuations in productivity might come from. Sometimes it could be at the reservoir level, sometimes it could be at the tubing level, sometimes it could be the surface. There's a lot of bottlenecking sort of challenges. So in that particular case, we also sort of train specific models based on that purpose. And sometimes, customers, they have their own sort of queuing workflows or equations. So it kind of depends on what the goal is, but we have flexibility from working with existing workflows or platforms to actually building to what is needed to achieve the goals. Does it make sense?
Yeah, it does. It does. And just curious again, in the back end here, you have
Mhm.
both. You mix, talking offline in the form you sent to me, you did put the emphasis on physics
Yes.
informed machine learning. So behind the scenes here, you do have machine learning models, but
We did.
with physics and equations and flow correlation or whatever the case may be. But you bring the physics in, and behind the scenes, you have both. You have machine learning and physics.
Absolutely. So let me give you an example. So
Yeah.
from a traditional machine learning applications, this is kind of a field benchmarking where based on predefined engineering KPIs, we can do clustering analysis to identify opportunities for optimization. But the main goal here is a field optimization based on well productivity benchmark. So in this particular case, you see the combination of both the physics side and the clustering, statistical clustering, kind of separate, but it's a good tool to kind of drive attention to what is needed to achieve a really, really high level. So what we see here in this particular plot is a dispersion of kind of wells based on gas rate, productivity index, gas liquid ratio. So obviously the main goal here is understanding why that dispersion, and based on the clustering analysis, we can understand where to go and start optimizing. Now,
Okay.
that is kind of physics and statistical tools in a separate way, more physics-based AI machine learning, which there are so many tools that we use. We have kind of models from neural networks to anomaly detection. This is one of the best sellers in the market. We take data, historical data, in this particular case, 10 years of production data that covers everything from historical production to workovers to nodal analysis to everything that you can capture in 10 years of production operations. What the system is doing is basically identifying potential production declines or potential production risk within a window 7 to 10 days ahead. And that is basically because of the learning process. So the system is flagging where a well may have an issue in the upcoming days, and it's also making recommendations on how to overcome that potential challenge. So here you have the combination of basically the AI or the machine learning training using physical or physics-based equations in order to understand how a well might behave in the future. And that just correlations between tubing pressure with downhole flowing pressure, with also compressor in surface. But the goal here is that kind of training, statistical training based on physics-based equations that are validated by historical data, if that makes sense.
Yeah, so in that example you were just describing, you're going all the way to the well performance, which we discussed at the beginning. Do
Mhm.
you also have like a standalone just production data analysis type of decline trends and things like that without having to have the
Absolutely.
the full well performance characterization?
Absolutely. So that is what you're asking is for sort of the automation of the traditional analysis. We have lots of tools in this particular kind of option. We have, this is trending analysis based on pressure drawdowns, productivity index. There are far more applications in the real-time trending analysis, which is basically enhancing the capacity to evaluate well performance in real time. And there are so many questions that we use here in order to evaluate, the declines of the well. So yes, you have the traditional tools focus on real-time data, high-frequency data, which is very different than having low-resolution data acquired every day or every week, which is normally what customers are dealing with in probably specific markets. So that's level one, automation of traditional workflows using real-time high-frequency data. Then you have the combination of statistical tools and physical or engineering equations, like I was showing you before. And then you have the next level, which is physics-based AI. And there is another level, which is basically the large language models that we can talk about it in a minute, but that's kind of the 4 levels of
Yeah,
application.
yeah, that's great. And obviously, this is the number one sell here is managing large production data sets. So it's all about
Yes.
production optimization, forecasting, opportunity identification, uh, flagging issues.
Mhm.
Yeah,
So one of the tools here that I think is really a good tool is about managing by exception, not only at the raw data level. So normally you can have alarms based on raw data, tubing pressures, casing pressures, temperatures, flow rate. What we do different than what the market is used to is that we use all these outputs from the different levels of value and generate alarms based on that. So for example, in this particular case, we can set up alarms based on the productivity index. So if the productivity index is changing dramatically within a window, and this is probably more offshore gas market, then you have an alarm that can be, delivered based on different setup models. So you can get emails, you can get a phone call. You can also set up your own equations and set up alarms based on your own equations. We do that for downtime identification based on anomaly detection. So if your compressor is basically, just follow me for a minute. You have gas leak, you have your compressors, and compressors are working 20 hours flat performance, and suddenly the compressor is driving downtime, then you have an alarm based on that sort of logic that you can customize in the system. So bottom line, you have the raw data, high frequency raw data, you have engineering calculations, you have process AI data for that kind of risk management tools that I was showing you about, and you can also customize the alarms, if that makes sense.
it does. Yeah, for sure.
So you
So
have you have 50 wells, 50 high producing assets offshore, lots of data. Today, I think we have about 6 million data points per day, capturing from surface all the way to downhole gauges. So you don't want to start checking everything every day. You can identify top 10 issues, and now you can have the flexibility to identify performance issues based on predefined engineering, AI predictions, as well as raw data. That's the goal.
yeah. And who is meant to be the number one user of this platform? It's the asset manager, and the platform becomes like a high level dashboard pointing out the important issues to focus on. Or do you see it more being used, on the operational level?
It kind of changes. We have, for example, in on land operations, the field supervisors, they use the data to really identify where to go and make changes. At more larger organizations, we have the production teams really, evaluating artificial lift performance. Offshore, we have asset managers, executive teams. Something that is really interesting, and let me show you here. So most of the time, the goal, uh, I don't know, I was talking about setting the goals for the system. So we kind of define this particular benchmark, and that benchmark changes with the organization. But In this particular case, this is the forecast, the corporate forecast, and the goal is to keep flow rates within that forecast. So in that particular case, executives are following the job as well. They just come and look, okay, there is some sort of alignment between what is expected versus what we are achieving. And there is lots of tools here for operations in terms of flagging operational events. So for example, just to give an example, let's assume for a minute that the production is declining here. It's not tied to the reservoir, it's tied to the surface operations. So you can have a database where you can automate all this kind of data management. So what we do here with operational teams in the field is to identify, create that digital database to explain well performance, which is different than well productivity, and that is just the relation with surface operations in order to really digitize the operations, especially offshore kind of mechanical operations. I don't
Hmm.
know if this makes sense. So the audience really changes with the goal.
Yeah, for sure. I'm always curious when introducing a new piece of tech, how the transition happens. So, in your view, or from what you've seen amongst your clients using your platform, how does the transition happen between conventional workflows using traditional software into using your platform? Because obviously, it's not just an add-on. I see you demonstrate actual analysis being done in platform. So back to the example of well performance or even declines. Um, so is it meant to become the tool where you actually replace and ditch traditional workflows and traditional software to be embedded within the entire Innovate AI platform ecosystem, or it's always going to be kind of a complementary, or at least there's a transitional phase? So how do you view that?
I think that's an interesting question. From our experience, I think it's more about the strategy. From a implementation perspective, you can see it's a tool, it's a software, it's SaaS. But in order to achieve these kind of goals where you can measure ROI, I think it's more about the strategy. And when you talk about strategy with new technology, then you're talking about management of change.
Yeah,
So from a deployment perspective, in order to achieve that ROI, there is a process. And the process is encouraged by the potential outcome. So there is a lot of management of change, technology exchange processes, validation. Obviously, being new technology, customers always rely on legacy tools to benchmark. But what really kind of makes the difference is that final outcome that is predefined ahead of the game, and the process leading to that validation is what really makes the difference from a long-term deployment perspective. So we don't see it as a tool, we don't see it as a software, we see it as a
a
strategy. And I
strategy from
think
the
that,
top down. Yeah, for sure.
well, you need both because the top-down one's performance, but the users are really the ones that can make the difference. So that's where the management of change came to the really comes to the question. You really need to have people understanding that journey from the goal setting to the goal validation and have buy-in from both sides, the executives as well as the users. So again, is a strategy more than selling a
Yeah,
software.
yeah, makes sense. What's the reception been? Did you say you guys were created in 2020?
Mhm.
So it's been a few number of years now. How are you guys doing? What's the reception been like?
Well, like I say, in terms of digital solutions, I think we are scratching the surface. I think there are so many opportunities for not only AI, machine learning, but lots of digital tools in the energy, wider now energy industry is being quite interesting. I think since COVID, organizations are more open to explore the value from digital. There is obviously a significant competitive landscape out there. I think sometimes marketing is really powerful, not only for education, but also for confusion. So it's really about those milestones where you can solely, in a solid way, demonstrate the contribution of that particular strategy based on digital tools. For us, it's been a journey. We built a comprehensive infrastructure from scratch, obviously lots of validation in the different sort of segments within the technology. Uh, We are really solid in the offshore market. I believe we are, well, as far as we know, we have the largest true AI production optimization projects in the Gulf today. In the land market, we continue growing with that dual approach, emissions management, production optimization. The commodity market also help us in 2026. I think when there is money, when there is cash flow, companies are more open to take risks. So it's been a journey, and I think it's about ROI validation where we can continue growing.
For sure. Well, there's no other way around than to play with the tool to understand the full capability. I saw a large of buttons on that left pane when you were demonstrating the software, so there's no other way around, as I said. But understanding that my audience is mostly subsurface professionals, reservoir engineers, production engineers, geoscientists, is there anything else you would like to highlight, or for my audience to go and have a look and have a bit of a play?
I think, if I may, I guess, late stage assets are a massive opportunity for digital tools, and for us, it's obviously a significant market. I think there is a lot of things that, from an engineering perspective, can be done in late stage assets, and the opportunity to automate, to bring more surveillance to the operations can make a significant difference. And from a technical standpoint, understanding that late stage of the asset and how you can react proactively to reservoir changes in real time, I think that's a massive, huge
Hmm,
opportunity.
that's interesting. All right. Well, Camilo, thank you very much for coming on. That was a very interesting walkthrough. Thank you for the update on what you guys are doing. And let's stay in touch and see what the audience thinks about this.
Sure. Thank you very much for your time, and I hope it's positive.
Absolutely, mate. Appreciate it. Thank you for coming on. Have
Thank
a
you.
great day.
Yes, sir. Bye.